where I of macOS on top of Windows as well, but the client experience will be different. You are going to work with the OC client, and even if an OC client is available for Mac as well as for Windows, the way it behaves is slightly different, and as the exam is going to be Linux-based, I recommend you do this on top of Linux. Good. Then there is this pool secret. The pool secret contains credentials. That is a separate file. You need this separate file to be present here. And that is what you are going to need to run. OpenShift local. I'm trying to adopt the terminology. You might catch me talking about code-ready containers a couple of times still. Hey, I have another question to you. It's one of these thumbs up, thumbs down questions. And I'm sending you the question right now. Can you let me know if you have your OpenShift local running or not? I want to know if you have a working environment to follow along, yes or no. If you feel you will have a working environment within half an hour, then that's okay as well. If you don't, I just want to know. I want to get a sense of what you guys are dealing with. I strongly advise, in order to follow along, to have your own working environment, because you need to practice this stuff. And honestly, folks, if you don't have your hands on an OpenShift installation to practice this stuff, well, you are never going to be able to prepare yourself for the exam. And wow, I can see that about half of you does not have a working environment ready at this moment. Okay. Apparently, I need to be more specific in the course registration page that you should prepare this before coming to class. Thanks, folks. I'm going to ask the question in another way, just slightly different, and I'm going to rephrase my question. This time, the question is: do you think before today's class is over, you will have your hands on to a working environment that uses OpenShift local / code-ready containers? Considering that you need about half an hour if you have a fast internet connection to install it, and you might need to download it, and the download is about 11 gigabytes. So the question is, do you think you will have your hands on to a working environment before today's class is over? Just rephrasing the question a little bit, trying to be aware of what you've got. Okay, if you need any instructions for setting up code-ready containers, I'm so happy to see that now everybody so far is answering, yeah, I think that is going to work. If you need instructions, the instructions are really very simple. It's a two-step procedure. You use CRC setup, you use CRC start. I can show you what I've done. And that is right here. SV is asking, can't we practice in Sandbox? No, totally, absolutely, completely not. SV, Sandbox for practicing in order to get yourself ready for EX280 is as useful as Windows 3.11 for learning Linux. So make sure that you have your hands on code-ready containers. There are no other options. Good. What are we going to do in order to get it up and running? Well, to give you a short summary, you run CRC setup, you run CRC start. So let me do history pipe grep CRC. And you can see I've done this multiple times. This is a machine that I've used forever already. And you can see CRC, where did it start? CRC setup right here and CRC start to install it. And then you need to do some additional stuff, and we will get there. But I wanted to have your attention for this already, so that while I am talking about the OpenShift backgrounds and other useful stuff, you might spend some time on performing the installation of code-ready containers. Again, I repeat, if you came here thinking that the OpenShift sandbox is going to be useful, it's absolutely useless in this class. Yesterday, because I was in trouble for a brief moment in time, I did a few commands from OpenShift Sandbox, and I just found out how limited OpenShift Sandbox really is. The purpose of OpenShift Sandbox that Red Hat is providing through developers.redhat.com is to allow a developer to run an application in OpenShift. You cannot even create new projects in OpenShift Sandbox. The purpose of EX280 is to teach administration skills about OpenShift clusters. And that means that you need administrator level access all the time, really all the time. And that is why I repeat that you really don't have a choice but to be on code-ready containers. JD has an interesting question. JD is saying, I did the exam 3 weeks ago, still in doubt if I should provide the certificates and key for creating a secure route. I thought that key certificates were supposed to be provided. JD, apparently you have not joined my class before. We will spend about an hour talking about creating your own self-signed certificates tomorrow. I cannot tell you what is going on the exam. There's no non-disclosure agreement. I'm always trying to find an elegant way to answer questions while still respecting the non-disclosure agreement. But let me tell you this way, there is a good reason why tomorrow, somewhere during the day, I will talk about an hour about how to create public-private key certificates, how to sign them, and all that OpenSSL kind of stuff. I also think I have some pretty good guidelines that help you to find that information on the exam. I mean, who remembers OpenSSL commands? That is just not doable. Okay, at any time, folks, if you have questions, I really appreciate your questions. Your questions make the difference between me talking sadly to my computer screen or me working with a group of people, and I rather do the second thing. I am going to spend some time in the introduction level topics just to make sure that everybody knows what we are talking about. I try to keep it short. The mission here is to get started with authentication and authorization as fast as we can. But also, while I'm doing this introduction level stuff, hopefully as many of you as possible can get their own OpenShift local up and running. So please have a look at the slides. Do be aware that when I'm shifting from my demo system to the slides, your interface does not automatically follow along. I'll always try to indicate what I am looking at so that you can manually follow along. And manually follow along, that involves clicking on either the second button from the left or the third button from the left in the course interface. The slides are under the third button from the left. Also, there's a course resources button, and you find a PDF containing all the slides in the course resources button. That might be helpful as well. Briefly, I want to tell you about OpenShift offerings. So a Red Hat OpenShift Container Platform, or RHOCP, which is the official name, extends Kubernetes with features that are commonly needed in a corporate data center. These features focus on the DevOps workflow. That's also the origins of OpenShift. In the beginning, OpenShift was a DevOps tool, heavily focused on Jenkins and CI/CD pipelines. Then Kubernetes became a thing, and rapidly OpenShift adopted and became a Kubernetes distribution. The first important release where OpenShift was a Kubernetes distribution was release 3. Nowadays we are in release 4, sub-release 10, so 4.10. Just one quick note about release 3. You may have heard of Minishift. Every now and then people come to class and ask, hey, can I use Minishift? Well, Minishift is based on OpenShift release 3. We are doing OpenShift version 4. And again, it's totally different. I repeat what I said before. The only thing that you can use is OpenShift local, aka code-ready containers. Good, there are different OpenShift offerings. There is Red Hat OpenShift Container Platform. That is a platform that is managed by the customer to provide OpenShift service on physical or virtual infrastructure, on-premise or in cloud. RHOCP, the message is do it yourself. no matter where you want to do it on your infrastructure. There is Red Hat OpenShift Dedicated. That is a cluster managed by Red Hat, currently offered on AWS, GCP, Azure, and IBM Cloud. I need to admit that I'm not that interested in marketing stuff, so I did not recently check to see if new cloud vendors are supported nowadays for Red Hat OpenShift Dedicated. OpenShift Dedicated, the main difference with OpenShift Container Platform is that Red Hat is managing the infrastructure for you. And that is probably good news because managing the OpenShift infrastructure is complicated. Apart from that, there are cloud provider managed OpenShift solutions as well. So that means that you can probably, in your cloud environment, you can probably run two different OpenShifts, either Red Hat OpenShift or cloud provider OpenShift. And it's important that you realize whose OpenShift you are using, because that determines where you need to go for support. There is Red Hat OpenShift Online. Red Hat OpenShift Online is a Red Hat managed OpenShift infrastructure, which is shared across multiple customers. From a technical point of view, the first three should give you kube admin access, or I should say cluster admin access. It's more appropriate terminology in the context of this class. In OpenShift Online, you get developer access. And that means that there are many things that you cannot take care of in the OpenShift environment. There is Red Hat OpenShift Kubernetes engine. The Kubernetes engine is just Kubernetes. That's for people who really are looking for a Red Hat supported Kubernetes distribution. It does not come with all the additional applications, which we call operators, that are providing the developer experience. And there is Red Hat Code Ready containers since recently rebranded as OpenShift Local. And Red Hat Code Ready containers is a minimal OpenShift installation, excellent for learning. If you just joined, that is what we are using in today's class. There's also OKD. OKD is the OpenShift open source downstream. I am calling it the downstream. Red Hat would say it's the upstream because normally in open source, the development starts in the open source community. And from there, the product is derived. It really feels as if in OpenShift, it is the other way around. Because from an OpenShift perspective, from an open source perspective, I do not consider OpenShift a very good open source product because open source is all about community and OpenShift is all about Red Hat. But the good thing is that Red Hat wants to be a good open source player. So even if OpenShift is a 99.9% Red Hat development, all the components of OpenShift are open source components and are available through open source projects like OKD, the OpenShift Kubernetes distribution. Right, talking about OpenShift components. So what is this about? Well, this is about what you find in the OpenShift product offering. So there are different components. It starts with Core OS. Core OS is the immutable operating system which is used as the operating system foundation. If you ever are going to build your own OpenShift cluster, which is not something we are going to do here, but if you ever would be doing that, you start with Core OS. And Core OS is immutable. And you just run Core OS as the OpenShift worker nodes. There is CRIO, C-R-I-O, which is the container runtime, which is used as a foundation to run containers. CRIO is a container runtime that is also used by Podman, and where Podman is running containers on a standalone stack, CRIO is running containers in a cluster stack. There is Kubernetes. Kubernetes is the open source orchestration platform. And I repeat, OpenShift is a Kubernetes distribution. It's a very fancy Kubernetes distribution, but in essence, it is still a Kubernetes distribution. And that makes it is good if you already know about Kubernetes, because your Kubernetes knowledge is applicable in the OpenShift environment as well. There is a web console. We are not going to see it here today because I consider it completely not important for the exam. And there are some pre-installed application services, such as an internal container image registry and a monitoring framework. And last but not least, there are certified container images for programming languages, databases, and more. If you have ever done EX280 or considered the core functionality of OpenShift, there is this component called source to image. And in source to image, you are going to build your own images based on your source code. And in order to do so, your source code is combined with these certified container images, and the result is a running application. Now we need to talk about OpenShift extensions. Now, what does that mean? Well, this is in the context of Kubernetes. Kubernetes provides a core product, we call that vanilla Kubernetes, with extensions that are used for additional functionality. And these extensions are delivered by external Kubernetes projects, and often there's a choice between different solutions. When I talk about external Kubernetes products, that is what is normally offered by what we call the Kubernetes ecosystem. The Kubernetes ecosystem is a lot of open source projects that are related to Kubernetes, that create solutions that work in a Kubernetes environment. And in the Kubernetes ecosystem, you can find different solutions that are doing more or less the same thing. These solutions are available in OpenShift. So each of the extensions come with its own API that can be integrated in the Kubernetes OpenShift solution. And all OpenShift extensions are standard Kubernetes extensions that could be added to any distribution of Kubernetes. I feel like visualizing this by making a quick drawing so that you better understand what is going on. So I'm switching to the drawing interface. If it doesn't pop up automatically on your screen, please click the second button from the left for access to the media player. So what is going on? We have core Kubernetes. And when I talk about core Kubernetes, we also call that vanilla Kubernetes. Vanilla Kubernetes is what you can install using kubeadm yourself if you're into the Kubernetes environment. Now, in core Kubernetes, they focus on specific functionality, and they leave out functionality that's taken care of by the ecosystem. And that means that if you install vanilla Kubernetes using kubeadm, you don't even get networking. And that is taken care of by the ecosystem, where we have solutions like network plugins. We have solutions like storage providers. Excuse me. We have solutions like ingress. We have solutions like observability. We have solutions like service mesh. And there are many more solutions. Now, for all of these solutions, there are different specific products. So there is not one service mesh, there is at least 3 that you could choose. There's not one ingress, there's at least 5 that you could use. There is not one network plugin, there is at least 10 different network plugins that you can use. And likewise for the other solutions as well. It's not my intention to try to be complete here. I just want to sketch what is coming from this ecosystem. Now, the products from the ecosystem can be integrated in core Kubernetes because of CRDs. CRD is custom resource definition. And custom resource definition means that you can extend the Kubernetes APIs to add new products into your environment. And a typical way to get these products in is by using operators, where an operator is an API extension that comes with a running application to make sure that you have a working environment. Now, what does OpenShift do? Well, OpenShift is a Kubernetes distribution, and as they call it, OpenShift is an opinionated Kubernetes distribution. Opinionated. And what does opinionated mean? That means that the OpenShift folks have an opinion about what should be integrated. So where in pure open source there is just one network, there is just a choice of at least 10 different network plugins. OpenShift picks one network plugin, the Multus network plugin. OpenShift picks two storage providers. They use one service mesh. They will use one ingress controller. They integrate that in OpenShift, and they are opinionated because it is all about support. From a supportability perspective, the Red Hat folks are saying, "Hey, if we would be supporting all these different storage providers, well, we can't do decent support, and that is why we make a choice for you." In the end, everything that you see here is open source, so you can build your own OpenShift using these open source components. But if you go for RHOCP, the supported OpenShift, which seems to be what the majority is using, then you work with this opinionated environment. And that's a little bit of background that I wanted to give you. CM is asking, is OKD vanilla Kubernetes? No, CM, OKD is not vanilla Kubernetes, because in OKD you also get this selection of ecosystem solutions, which is the same as what you would find in an OpenShift environment. Good. I'm switching back. You can't see the drawing interface anymore. You should be able to see my demo interface. And I am going back to the slides because I have a little bit more to tell you about. In case you are wondering how much blah blah before we really are getting started, well, I have one more slide. Then we talk about code-ready containers. And then I am going to tell you very briefly about the OpenShift fundamentals. Folks, just to make sure that those who have not done EX180 and the OpenShift introduction, I will spend less than 1 hour to summarize the essentials about projects and running applications and such. I'm really minimizing it because I think we should spend our time on the important stuff here, but I don't want to completely ignore it, just to make sure that if you don't have that knowledge, you still have a chance of following along and getting knowledge that you need to acquire. Just my friendly advice, if this is your first class in OpenShift, I really think that you should be starting by taking a class like EX180, which is teaching you about OpenShift fundamentals as well. Before you can do administration, you should really know about the basics. So I would like to talk about OpenShift installation methods. What is that about? Well, that is about how you are getting your hands on to an OpenShift environment. And depending on how you are going to use OpenShift, you might not even have to install it. As just discussed, there are many options to use OpenShift as provided by some provider, by some cloud environment. Now, Red Hat OpenShift Dedicated is one of these examples. It runs in cloud, it's managed and installed by Red Hat. So you just have to use it. And Red Hat OpenShift Container Platform is what you can install on-premise. If you happen to have access to Red Hat Learning subscription, Red Hat has a workshop in which they teach people how to install your own Red Hat OpenShift Container Platform. I think it's a 3-day workshop, which is just a nice indication of the complexity of the OpenShift installation. My 2 cents about it: if you are if you would have like a week of vacation and you think, let me do something useful, and instead of going to the beach, let me install my OpenShift cluster. To start with, you need to make sure you have sufficient resources. A total amount of 128 gigabyte of RAM is not exaggerated. And secondly, count on using the entire week before you have your own OpenShift cluster up and running. Installing your own RHOCP is not easy at all. Good. We also talked about OpenShift Online, which is managed and installed in cloud, and OKD can be installed on-premise. Code-ready containers, aka OpenShift Local, provides a minimal installation that you can run on your own laptop. Oh, and I'm just thinking about all the slides that I need to change where I'm talking about code-ready containers. Good. Here I'm going to summarize performing a code-ready containers-based installation. And when I say summarize, to do so is that your host operating system must be capable of offering a virtualization. In macOS, in Linux that is easy. In macOS that can be easy. In Windows, you need to have the right version where Hyper-V is available. So if you are a Windows user, you want to install on top of Windows, check if you've got Hyper-V available. Good. For the rest of it, I am just going to summarize what is important. VK is asking, is there a different chat where we get these links? VK, that is the group chat. And the group chat is the leftmost button in your interface. So, folks, there are two buttons in your course interface where you can post questions. The group chat is all the way to the left. That is where I just posted the link. The Q&A VK is what you've just used. And in my interface, that shows all the way to the right. Glad you got it. Nice. Let's continue with... just one slide. I'm not going to do the CRC on Linux. I will do, well, no, not one. I will do two slides. So first, developers.redhat.com. You can get access to code-ready containers, now known as OpenShift Local, which is the all-in-one Red Hat licensed version of OpenShift 4.latest. You will notice there's a new release of OpenShift Local every 3 to 4 weeks when there is significant changes in the source code. The nice thing about code-ready containers is that there is no expiration. So you run it on your own laptop, you run it as long as you want. But you will notice that at some point you bring it down because it's a heavyweight. You don't want to have it running all the time because you might need the computing resources for other stuff on your computer. And every couple of weeks it will tell you newer version is available, go here to download it. And when the newer version is available, I would just advise you go get it and start using it. Even if code-ready containers allows you to explore all the functionality of OpenShift, Red Hat really doesn't want to offer it as an alternative to OpenShift. That is why I'm a little bit surprised by the name shift, OpenShift Local, that suggests as if this is completely different. So CRC works on Mac, on Windows, and on Linux. And the system requirements are heavy. You need 4 vCPUs. You need 16 gigabytes of RAM on your operating system, and you need at least 35 gigabytes of available storage. Also, you could use OKD for, hey, do yourself a favor, don't even try. It is complicated. And I can promise you one thing, if you are trying to use OKD4 instead of OpenShift Local, you'll spend all the time you are in class on getting it up and running. And by the time you have it up and running, this class is over. In order to get CRC, you download an archive as well as the pull secret from developers.redhat.com, and then you are good. Now, if you want to install it on Linux, Red Hat Family is supported. Red Hat Family, that means CentOS Stream, Red Hat, Recent, Fedora. That does not include a Rocky Linux. I get reports of people who are running it on Rocky Linux, but honestly, I think you are spending your time in the wrong area if you try to get it on Rocky Linux. I mean, Red Hat Enterprise Linux is available for free. CentOS Stream is available for free. Why would you want to do it on Rocky Linux? Really, I don't know. Make sure you have libvirt and network manager available. These are the minimal requirements. And then you run CRC setup. CRC setup is going to download an 11 gigabyte container image. And once it has done that, you can use CRC start with all of the different options. On the slide, you can see CRC start -p pull secret -m 12 that will start code-ready containers with 12 gigabytes of RAM. That is the -m, and the -p pull secret refers to the pull secret, which is a file that you have downloaded on your computer. You need both of them, otherwise it can't start. Now about the amount of RAM, code-ready containers does start with 8 gigabytes. It will take forever, and you will run out of available resources pretty soon. Yes, CM, I would avoid installing code-ready containers OpenShift local inside a virtual machine. Just sharing my experience here, CM, last couple of times that I tried, and I tried stuff like this not one time, but 5 times before I have an opinion about it. I did try it about 5 times. I do have an opinion. And the opinion is that I have seen all weird kind of trouble while trying to run code-ready containers inside a virtual machine. The thing is, if you run it in a virtual machine, then there is the virtualization layer. There are so many differences in the virtualization layer that the code-ready containers developers have never even considered. Another thing that I want to mention, if you are on macOS, I can confirm that code-ready containers works like a charm on macOS Intel. I cannot confirm how it works on macOS M1. I have not recently tried that, but I can only tell you that running virtual machines on macOS M1 is a pain in the beep, and that is because on macOS M1 it needs to be on ARM infrastructure and not on Intel infrastructure. So I'm afraid that running in macOS M1 architecture is also going to be problematic. Good. Once you have CRC up and running, you can use CRC console. CRC console is the most useless command I'm going to tell you about. There's only one thing that is useful, and that is CRC console -- credentials. What is that doing? Well, let me just show you. If I use CRC console -- credentials, then I get my login credentials. So to log in as a regular user or to log in as the admin user. Now I am going to make sure that I have this one in my history. Now the thing is, and this is something that applies to the exam as well. If you're on a new OpenShift cluster, you need to be able to log in. Somebody needs to tell you what is required to log in. In code-ready containers, that is CRC console -- credential. Guess how useful that command is on the exam? It completely is not. But on the exam, you will find the exam instructions, and the exam instructions will tell you how to get into your OpenShift environment. I'll tell you more about it once we have learned about authentication and authentication providers and all that kind of stuff. Now, if you are immediately trying to log in by copy-pasting this command, you might find, and that is in CRC as well, you might find that it is not working out immediately. And that is because the OC binary is not in your path environment. So what are we going to do about that? Well, there is CRC OC env, and that is printing that you need to run this command to configure your shell. So this is the command that you are going to run. Let me copy, let me paste, and whoop, and then you have full access to the OC binary. Now, if there is one thing that you need to be very careful about in EX280, then it is who are you? In EX280, you are switching user accounts all the times. So be very, very, very considerate who you are. So also, who am I is telling me that I am currently the Kube admin user. The Kube admin user is the default user that is created in OpenShift that has cluster-wide permissions. You use that user if you want to change cluster properties. It's a little bit like the root user on Linux. You only use the root user if you want to change properties of the Linux operating system. You are not going to use this user if you just want to do whatever you want to do. So in that case, you use your developer user. So here I am in my developer user, and you can see that this developer user already has a couple of projects. Yes, I used this setup in the class that I've been teaching yesterday. That should not influence what we are doing here today at all. But OC login -u username is the first important thing that you need to do to get access. Right. One more slide about this CRC. And that is CRC considerations. Code-ready containers need to be rebuilt often, and that's because Red Hat doesn't want you to use it as a permanent solution. They want you to spend your money on OpenShift. If you are going to tear it down, use CRC delete, CRC cleanup. CRC cleanup really cleans up the old cluster and ensures that there is nothing remaining about the old cluster. The main reason why you are tearing down your old cluster and going for a new cluster is because a new version has become available. There is no in-place upgrade. Red Hat doesn't want you to do in-place upgrade using CRC. They want you to run the new version. If you want something that is upgradable, you should go for the real thing and spend your money. Now, in order to do so, CRC cleanup, then you do your CRC setup and your CRC start. And yes, you will have lost all resources that you have created. You do need to make sure you have a pull secret, because the pull secret contains your credentials. Red Hat is giving away OpenShift Local, also known as code-ready containers, for free. But it is connected to a developer's account that you can get for free through developers.redhat.com. And they do want to know that you have a valid account. We have just seen CRC console -- credentials is what you use in code-ready containers to print your current details. And if you want to log into the console, well, I don't care about that, because we are not going to do that here. CRC OCenv is what we have done. We have talked about logging in as developer. And then there's this nice command that you can use to test. Let's do that. OCgetCO. OCgetCO is doing what? Oh no, it's giving me already my first error message. Folks, this is something that you are most likely going to see a lot. This is a role-based access control. Role-based access control, also known as RBAC, is all about permissions. And what do we get? We get clusteroperators.config.openshift.io is forbidden. Why is that? Because CO is a cluster operator. And cluster operators really is about ecosystem applications that have been installed in OpenShift. That is not something that is accessible to the developer. This is the world of the kubeadmin user. And that is why I'm getting this is forbidden. And if you get this is forbidden, well, you are using the wrong identity. So I'm using Linux Control R for a reverse iSearch, and I'm reverse iSearching on kubeadmin, and I'm using OCgetCO again. And what do we get? We get an overview of all the cluster operators that are available in our current version of OpenShift. Getting back to the developer view, because I think it's nice to start from the developer view and always be conscious about the specific view that we are going to use. I'm skipping one slide, and we are going to talk about our next topic, which is working with projects. Everybody, this is my absolutely less than 1 hour summary of the OpenShift basics. Again, I want people to be aware of what we are doing, so I quickly want to talk about projects and how to run applications. But really, I do expect you to already know about the OpenShift foundations. So this is not the class where I'm going to tell you what a pod is and what a deployment is. Before moving on, SG had a question. SG was asking, how different is Podman with CRC? SG, my sincere advice, come and join EX180, in which I will be very detailed in the answer. Here I will be very short. Podman is standalone. Code-ready containers is OpenShift, and that is all about orchestrated containers. But SG, honestly, this is a question that belongs to EX180, not so much to EX280. And yes, my friends, I need to be strict and I need to be filtering questions that are irrelevant to this course, because we have enough to do with the stuff that is relevant. And my holy mission here is to do strict time management and to make sure that we use our time as efficiently as possible. Good. Projects. I want to tell you about projects. Folks, I'm looking at the slides. If you don't see the slides at this moment, please click the third button from the left in the course interface to follow along. So what is a project? Well, in order to understand OpenShift projects, we need to start with the Linux kernel. In the Linux kernel, there are these things called namespaces, and namespaces offer strict isolation between processes. Namespaces are essential for containers, and they make that a container can only see their own stuff and they can't see stuff that matters for other containers. Now, Kubernetes is about orchestrating containers, and OpenShift, being a Kubernetes distribution, uses Kubernetes technology as well. And Kubernetes implements namespaces in a cluster environment. If you have ever done Kubernetes management already, then you know that there's a kube system namespace that contains all the administrative pods, and there's a default namespace in which the user applications are running. Namespaces are also used in OpenShift environment. And namespaces are cool because you can use them to limit inter-namespace access. A namespace by some providers is sold as a virtual data center, and that really means that you get your own isolated environments. Also, and this is very important, and we are going to do a lot with this throughout this course, namespaces are used to apply resource limitations. Namespaces are also used to delegate management tasks to users. RBAC, or role-based access control, is what we are going to apply to namespaces. Now, OpenShift implements Kubernetes namespaces as a solution to manage access to resources for users. And in OpenShift, namespaces are reserved for cluster-level admin access. Users have projects. And user projects are used to store user namespaces. Now, what is the confusion all about? Well, the confusion is that namespaces are good because namespaces allow administrators to provide isolation at the cluster level. But maybe as an ordinary user, you also want to provide isolation between different applications. And that is why for ordinary users, OpenShift is providing projects as API resources. And a project, and that is kind of funny, if a user creates a project, the administrator will see the project as a namespace. I have a brief demo in which I'm going to show you how exactly this is working out. So let me start. OC-get NS. Folks, for your information, most of the demo in some way are in slides. I like to improvise, so you might see that my demos sometimes are slightly different, but I will make sure that by the end of every day of class, I am providing my course history. I'm creating a pastebin containing my entire course history, and that makes it easy for you to play back the commands that I am using. Oh, one more thing that is convenient. I do not really like questions like, can you repeat what you just said? But if you translate that question to one single word, and that is the word history, I will always type history in my console as fast as possible so that you can see what I've just done. So if you just missed what I was doing, just post the word history in either the group chat or in the Q&A, and I will type in history as fast as I can so that you can check what I've been doing and try it for yourself. That proves to be an efficient way that avoids me from repeating what I just said, and which helps you in doing what I just did. Good. I need to get back to my kubeadmin view. This is also something, folks, that I really recommend that you do on your exam. Once you have access to your cluster, you make sure that your kubeadmin login is somewhere in history. And once your kubeadmin login is in history, you can use Linux Ctrl+R, the reverse iSearch, and you just type kube, and it will bring you back most likely to the last command that you use to log in as kubeadmin.